Okay, hello Year 8. So what we're going to do today is we're going to start to see how certain atoms can stick together, what we call bonding. Okay, so hopefully by the end all of you will explain why atoms bond together to form compounds. Most will be able to define the term ion, and a few of you will be able to use a model to show how bonding takes place. Okay, so what I'm going to do is firstly, I'm going to explain to you what an ion is, um, and then we're going to see how these bonds, so basically how the atoms stick together. And to do that, they need to undergo a very slight change. Okay, so we're going to go through a few simple examples with you and see what they come up with. Okay, so firstly, let's just say that these red circles here are protons, the blue circles are neutrons, and these small green circles, these can be electrons. And we're going to take a really, really simple atom here. Okay, we're going to take lithium. Okay, so lithium has the chemical formula Li. Okay, now if you look on the periodic table, you'll see that it's got 3 protons and 4 neutrons. So if we just build its nucleus like this, okay, so there's a lithium nucleus. So it's got the atomic number of 3, a bit smaller, hold on a moment. Sorry, the atomic mass of 7 and the atomic number 3. Okay, we'll just quickly shift these around. And there we go. There's lithium. Okay, so we've got 1, 2, 3 positive protons, which means in order for this atom to be stable, we've got to have 3 negative electrons. And as you remember from last lesson, electrons are in orbit around the atom. So what we'll do is we'll draw those shells in. Let's just make those fraction bigger so you can actually see it. There we go. Right, okay. So we're going to now put our electrons in. So hopefully you remember the rules. You put up to 2 in the first shell. Now that outer shell, sorry, that shell is now full. So we'd have 1 in the next level. Okay, so there's a lithium atom. But some of you might have started to see a little bit of a problem with this. Okay, now there is a golden rule. Okay, and the golden rule is this outer shell always wants to be filled up in order for it to be stable. So essentially, we'll just write that in because that's actually a really important point. Okay, the outer shell always wants to be full up to be stable. Okay, here's the question. Okay, how many more electrons could we put in here? Okay, so for those of you that remember, these can hold up to 8. So we've already got 1. So you'd need to put another 7 in here in order for this to be stable. Okay, is there an easier way that this could get a full outer shell? And also, some of you probably spotted that if you had 7 extra electrons, there'd be way more electrons than there would protons. Okay, so the way it works is this. Okay, I suppose the question is it easier to ditch 1 and gain a full outer shell or gain 7? Right, now hopefully some of you will see the obvious answer is to just ditch 1 electron. So let's just get rid of him and put him over there. And now you can actually also get rid of that. And now look, you've got a full outer shell because remember the first shell only holds 2. Okay, now that does create a problem because you've got 1, 2, 3 positive charges, but 1, 2 negative charges. So you've got more positive charges in the protons in the nucleus than you have negative charges, electrons, going around the outside. And so This is still lithium because it's still got its positive protons. It is still lithium, but it's no longer a lithium atom. It's what we call a lithium ion. So, because of that, we give it a little plus symbol, and it goes in little square brackets like that. So that's lithium. Okay, that's a lithium ion. And so the whole thing is this outer shell always wants to be filled up to be stable. And so atoms have a choice. They can either ditch electrons or they can do something else. Sometimes they can gain them. And I'm going to show you an example of that now. Okay, welcome back. So I'm going to start with oxygen. Okay, so oxygen has an atomic number of 8 and an atomic mass of 16. So firstly, I'm going to need 8 protons and 8 neutrons to bring its mass up to 16. So let's just do that. Okay, welcome back. Now, what we've got here is oxygen. And if you count carefully, you can see we've got 8 protons. 1, 2, 3, 4, 5, 6, 7, 8. And we've got another 8 neutrons to bring it up to 16. 1, 2, 3, 4, 5, 6, 7, 8. Whoops, I have accidentally added an extra one, so let's just get rid of him. Sorry, that was a mistake on my part. Move you around. There we go. Right. Okay. So we've got 8 protons, which means we need 8 electrons going in the going in the shells. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so as you can see, oxygen has got 1, 2, 3, 4, 5, 6 electrons in its outer shell. How many does it need to have a full outer shell? Well, it needs 2. So here's the question. Is it easier to ditch 6 or gain 2? Okay, right. Hopefully your answer is quite easy. It's much easier to gain 2. So that is what we will do. So what happens to oxygen is this. It gets 2 extra electrons in the outer shell, but there's a problem. Okay, there is a problem with this because look, we have 8, 1, 2, 3, 4, 5, 6, 7, 8 positive protons, but now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negative electrons. Okay, so 8 positive charges, 10 negative charges. So overall, this has got a negative charge. It's more negative than it is positive. Okay, and so this is now an oxygen ion. Okay, so once again, we draw in some square brackets to show, and that's just our little way in chemistry of showing that it's an ion now. But there is something that's slightly different. Rather than just putting a negative, because there's 8 positive charges and 10 negative charges, it's actually minus 2. Okay, it's 2 negative. So this is an oxygen ion. Right, here comes the challenge for you. I want you to now draw out a sodium ion and a chlorine, sorry, to be more specific, a chloride ion. So this is your task. Using the similar example that I've just done, I would like you to draw out a sodium ion and a chloride ion. Okay. Okay, so draw very similar to what I've just done here, a sodium and a chloride ion. So you'll need to look them up. So how many protons and how many neutrons does a sodium ion have? And then the same with chlorine. Okay. So pause the video and do that now, please. Okay, welcome back, Year 8. So this is what you should have got, and it looks a bit complicated, so I'll just quickly talk you through it. But essentially, your sodium ion Na should have had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 protons, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 neutrons. So its mass was 23. So basically what we're really interested in is 11 positive charges. Okay, so there's 11 red protons, 11 positive charges there. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11 negative charges, 11 negative electrons. Chlorine is the same. We've got 17 reds in there, if you can be bothered to count them. And then, of course, you've got your neutrons, which would be 13, I think. Is my arithmetic correct? Apologies, no, it's 18, sorry, neutrons. But it doesn't really matter. We're not really too interested. But we have 17 electrons going around the outside. Okay, so if you remember the earlier thing, the outer shell always wants to be full up to be stable. Okay, now this is where certain elements start to cooperate. They do something called ionic bonding. I'm going to explain what it is. Now, we'll start with sodium. Okay, so look at sodium. How many electrons does it have in its outer shell? It's got 1. So the question you would ask is it easier for it to get a full outer shell by ditching 1 or trying to gain 7 to fill it? The obvious answer is it's easier to ditch 1. Now, chlorine's got a slightly different problem. Okay, if you count how many electrons there are in this one's outer shell, there are 7. 1, 2, 3, 4, 5, 6, 7. So is it easier to try to gain 1 or ditch 7? Of course, the obvious answer is gain 1. So what happens is chlorine and sodium sort of form a bit of a partnership, I suppose you'd almost call it. Sodium says, look, I'm desperate to get rid of 1 electron. Chlorine says, look, I'm desperate to gain 1. So what happens is this. An electron moves across, oops, and joins this one. Sorry about that. Okay, so now we have this. Now, if we count sodium, 1, 2, 3, 4, 5, 6, 7, 8. It's got a full outer shell. It's stable. It's happy. Chlorine, 1, 2, 3, 4, 5, 6, 7, 8. It's got a full outer shell. It's happy. But there are some side effects from this. There are 11 positive charges, but now only 10 negative charges. So what's happened is sodium has become a positive sodium ion. Okay, so this is what you've got. You've got sodium, which is a positive ion, but chlorine, remember it had 17 positive charges, but now it's got 18 electrons, so it's slightly negative. And what do positive and negative things do? Well, positive and negative, like north and south poles of a magnet, they attract each other, they stick together. So if I just quickly move this out of the way, essentially what happens is this. The positive sodium will move towards and stick to the negative chloride ion. And so they'll stick together like glue. And then you have got the chemical formula. Just quickly write it down here. NaCl. Ladies and gentlemen, that is a very long-winded way of how you get salt. So for your next task, I'd like you to just pause the video another time, one more time, please. And I'd like you to just go to your kitchen and I'd like to pour a few grains of salt out into the palm of your hand. And what I would then like you to do is if you've got a magnifying glass to hand, have a really, really close look. You can probably see what I'm going to ask you to look for, just if you look at it really, really close up. What is the basic shape of a grain of salt, roughly? Okay, so have a rough look. What is the shape of a grain of salt? All right, so pause the video now, go into your kitchen, have a quick look, and then write down in your book what you notice. Okay, now hopefully what you noticed was it was a sort of cube structure like this. Okay, now this is how sodium chloride bonds together. You've got the sodium, the purple, and the chlorine or chloride ions. And what happens is because the sodium is positive and the chlorine is negative, they stick together like glue in this regular structure, giving you cubed crystals. And so hopefully what you saw was something like this, okay? This cube structure in your table salt. So if you didn't, pause the video again and go and have another look, okay? You get this cube structure. It's very, very organized. And that is the process of ionic bonding. You've got these two ions that stick together and form a bond. Right, okay, so for the rest of the lesson, just to be really clear, what we are going to do is this. Firstly, make sure you've got the definition of an ion. So an ion is a charged particle. Now, I've used the example of sodium and chlorine, but there are other elements on the periodic table that can become ions. For example, everything in in group 1, so sodium, lithium, everything below it, they can all become charged particles, and so can some of the ones on the other side. Okay, so can, for example, chlorine, fluorine, bromine, aluminium, oxygen, they can all become charged particles. Okay, and this whole thing is they lose or gain electrons to get that full outer shell. That is the main idea, and if you don't remember anything from today's lesson or you couldn't quite work some of it out, remember that atoms are always trying to get that full outer shell to be stable, okay? And they'll do it any way they can. And if that means losing or gaining electrons and becoming an ion, so be it, okay? The full outer shell to them is more important than being neutrally or balanced charge, okay? So that's the main thing you need to remember, okay? So don't worry if you didn't understand everything today. There's a lot of detail in here, but do try and make sure that you understand these key points. Okay, so what I'm going to do now is I'm going to put a video in assignments for you, so you can have a look at that about ionic bonding. And then there is going to be a task. It includes some of the stuff we did last lesson and finishes off with what we have done this lesson. So that should probably take you the rest of the lesson to do. Okay, it might even take you a fraction longer. Okay, but certainly don't take any longer than about 50 minutes or so in total. So that will give you about half an hour left. So the video and the sheet shouldn't take you more than about half an hour from when you end this video. Okay, right, good luck, and I'll be online if you need any help.